Hi, I'm Mr. Huber, and in this video I would like to talk about exercise 12a. Well, in the right-angled triangle ABC with the hypotenuse C, we're given C and A. And we want to work out the angle bisector W alpha and W beta. Well, the angle bisector W alpha, well, you could draw it like this with a pair of compasses. Here we go. Then you draw that angle bisector. So please, it's important to note that we're looking for the length of this line, W alpha. We're not looking for half of the angle. We're looking for the angle bisector. And then, well, you could do the same thing for beta. Yeah, more or less, okay. The angle bisector for beta, and you're going to get this. So let's highlight this one in red. Or maybe this one. Let's highlight this one in red. This is W beta. So what we're asked to do is to work out the length of this line and the length of this line. So that's not too difficult to do. But what you have to know, we're looking for the length of two lines. So first, we could work out alpha, okay? So let's work out alpha. It's opposite over hypotenuse, so sine of alpha, opposite over hypotenuse, so 24 over 74. In order to work out alpha, we need the inverse sine or arc sine. So arc sine of 24 over 74. So let's type this in, arc sine 24 over 74. So we're going to get 18.92, approximately 18.92 degrees. Let's store this as A, okay? We might use it later. Well, once we know A, we know beta, because alpha plus beta plus 90 degrees is 180. That means alpha plus beta is 90 degrees. So you can work out beta. So beta is approximately equal to, that's 71.08 degrees. Okay. Good. Well, once you know alpha, you can work out B, okay? Let's work out B. Or you could work out B even by using Pythagoras. Well, let's do that. Why not? Why not? So B is, well, let's do it like this. Let's write it properly. A squared plus B squared is C squared. So B is C squared minus A squared and the square root of it. Okay, so let's do that. Square root of 74 squared minus 24 squared. So that's 70. So B is 70. Good. Now we know B 70. Now look, we're almost done now, because we have to look for right-angled triangles. And this here is a right-angled triangle. We know the adjacent side. We don't know this side. Well, don't make the mistake that that you think this is right in the middle. It's not. Look, with the red one, you can clearly see that. The angle bisector does not bisect the opposite side. It almost looks like it, but well, it does not, okay? We know the adjacent side, And we know alpha halves because we worked out alpha. So then we know alpha halves. That means we can use the cosine in order to work out W alpha. Let's see how that works. Look. Cosine in this blue triangle of alpha halves, okay? Alpha halves, because this is the angle bisector. We know alpha, so we know alpha halves is adjacent over hypotenuse. Adjacent is 70, that's the B in this blue triangle, and the hypotenuse, the one opposite to the right angle, is W alpha. Look how great that is, because now we can work it out. We just type in cosine of 18.92 degrees over 2 is equal to 70 over W alpha. Then we multiply everything by W alpha. So we get W alpha cosine 18.92 divided by 2 is equal to 70. I'm carrying on with this because I'm going to use the stored value. And then W alpha is 70 divided by cosine alpha halves, which is 18.92 degrees over 2. Let's not forget the degree sign. So now this is what I type in. 70 divided by cosine, well, recall A, divided by 2, that's half of alpha. So let's type this in, and we're going to get 70.97. This is 70.97 units of length. So we used this triangle. Now let's do the other one. Here, W beta, because we can work that out too. We know that in this triangle, we have a right angle. We know the adjacent side. We don't know the hypotenuse, which is W beta, but we do know beta halves because we know beta. Okay, so let's work that out and do the same thing. Cosine beta halves is now adjacent, so 24 in the red triangle, over the hypotenuse W beta. That's what we want to know. Good, let's calculate this. Let's type this in. Cosine beta is 71. 71.08 divided by 2, 24 over W beta. So you multiply by W beta. So W beta is times cosine of 71.08 degrees over 2 is equal to 24. Then you work out W beta. 24 divided by this term, cosine 71.08 degrees over 2. When you do this, you're going to get W beta is approximately equal to 29.49 units of length. So the thing to remember here is they wanted us to calculate W alpha and W beta. Okay, so we're not asked to work out alpha halves or beta halves. We're asked to work out the length of the line, this very special line W alpha and W beta. We're asked to work that out. So I worked out all the sides and all the angles in this triangle. And then I was able to use the upper, the blue triangle, because that's the right one. We can only use trigonometry in right triangles in order to work out the length of W alpha. And I did the exact same thing with the length of W beta. Okay, I hope it wasn't too difficult. See you in the next one.